What is up, Algebros? This is lesson 95, and our objective for today is how to find the volume of right solids. So they're all girl solids. Just kidding. It means that their height is perpendicular to their base. So first of all, we need to talk about what is the volume of something. We've talked about the perimeter of something. That's talking about how, like, a length, how far would it be to go around the edge of it. The area is talking about how many squares it would take to cover it up. Thinking about like sticky notes, how many sticky notes it would take to cover up a wall. And volume now is talking about cubes. How many cubes of a set size, for instance, like this cube here that's 1 inch by 1 inch by 1 inch. If I were to get, thousands of these, I guess, how many 1 inch cubes would it take to fill up my classroom? Or how many 1 inch cubes would it take to fill up this box? How many 1 inch cubes would it take to fill up that bottle? So sometimes we talk about cubic inches, sometimes we talk about cubic centimeters. It just changes the size of your box. Now, some boxes are really nice to find out how many of those cubes it'd fit into, like this one over here we'll talk about in a second. And sometimes you end up having to like shave them off, or even like if you're talking about a cylinder, you have to like shave them up into a powder and pour it in there in order to really calculate that properly. But that's what we're talking about when we're talking about volume, is how many cubes it would take to fill some object. So when we're talking about the volume here, think about this box here. I'll outline it in blue, this box here. What's the volume of this box? Notice it is 2 inches wide, 3 inches tall, and 4 inches deep, right? 4 inches deep, or 4 inches wide if you want to think of it that way. So how many cubes would fill in there? Well, we could just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, so we'd say, okay, there's 24. But that's not too bad on this box. What if it was like 50 inches wide and 100 inches long and 75 inches tall? Well, that's a lot of boxes to try to count. So let's see if we can come up with a concept here that we could use to then calculate the rest of it. So notice this is 2 wide, and then it is 4 long. So I'm going to think about how many boxes are here just on this bottom layer. Well, 2 wide, and there's 4 of them this way, so you can think of 2 times 4, which give you 8, right? So there'd be 8 on a single layer, and then multiply it by how tall it is. How many layers would fit in this box? So it'd be 1, 2, 3 layers tall. So you do 8 times 3. We get you that, which is 24. Or you could think about, oh look, there's 2 wide and 3 tall, so I could talk about layers this way. There's 6 here, and then there's 4 layers that way. So 6 times 4, again, get you that same number of 24. Okay. So in summary, if you want to find the volume of something, you multiply the area of the base, that's what we're talking about here, the 2 times the 4, and then you multiply it by the height of your three-dimensional object. We already know how to find area, so you just find the area of the base and then multiply it by the height. So remember, if you want to find the area of a rectangle, that's just base times height. If you want to find the area of a triangle, you say base times height and then multiply it by 1/2 or divide it by 2. If you want to find the area of a circle, that's pi times r squared. So these formulas are the ones you're going to be using for the area of the base in your volume formula. So like earlier here, the area of the base, since it was a rectangle, we used that base times height. So 2 times 4, and the height of the whole thing was 3 inches. And then, so 2 times 4 is 8, 8 times 3, 24 inches tall. All right, so this is example 1, and then we're going to do example 3. It says, find the volume of the right triangular prism below. Now notice it told us what shape it was. It's a right triangular prism. So remember, we name prisms by the shape of their base. Now sometimes we're tempted to think, oh, the base of this is a rectangle, but it's not, because it's a triangular prism. Remember, the bases are parallel to each other. So this rectangle down here is not parallel to this rectangle here, but this triangle is parallel to that triangle. So the base is a triangle. So as we go through trying to solve this, I'm trying to find the volume. So it's going to be the area of the base times the height. Well, remember the base is a triangle, this triangle right here. So that's going to be 1/2 3 centimeters times 4 centimeters. And then the height, this height right here, is the distance then between the two bases. In this case, it's going to be 6 centimeters. So multiplying these, 3 centimeters times 4 centimeters is 12 centimeters squared. Then I'm going to multiply that by the 6 centimeters. Remember, because the centimeters times centimeters gives me centimeters squared. I want half of the 12, so that's going to give me 6 centimeters squared. And I'm going to multiply that by the 6 centimeters. And my final answer is going to be 6 times 6, which is 36. Centimeters squared times centimeters is going to be centimeters cubed. So the volume is 36 centimeters cubed. So I could take 36 of those. I would probably have to cut them, strangely, of those cubes that are 1 centimeter on each length. But I could fit 36 of them inside of that triangular prism there. Now example 2 is a little bit different because it's the diameter of the right circular cylinder, which all cylinders are circular, is 20 centimeters. So let's go and draw that on there. It says the diameter, so it's all the way across. That is 20 centimeters. Its height is 25 centimeters. What is its volume? Leave pi as pi. So to find the volume, I know I need to find the area of the base times the height. Well, what shape is the base? Yeah, that's right, it's a circle. So I'm going to say pi times r squared times the height. So let's see if we can plug in some numbers here. Recall, please, that they said the diameter is 20 centimeters. 20 centimeters. So that means the radius is going to be 10 centimeters. So as we plug this in, this is going to be pi times 10 squared. And the height is the distance between my circles, which is going to be that 25. So 10 squared is going to be 100. And then I'm going to multiply that by 25. And so our final answer is going to be, well, 25 times 100 is going to be 2,500 pi. And I forgot to put my units in here, but these are all in centimeters. So it'd be like centimeters here and centimeters there. So centimeters squared would come out here, times centimeters there would give me centimeters cubed. All right, one last one here. It says a farmer added an attached shed with the dimensions shown to the side of the barn. What is the approximate, let's go ahead and highlight that, approximate volume of the addition? List the steps needed to find the volume. So we're just going to show our work is what it's asking us to do there. So first of all, since it said approximate, I don't need to worry about all of these inches, right? So this 7 feet 11 inches is pretty much the same thing as 8 feet, okay? 10 feet 1 inch, well, that's really just, let's just say that's 10 feet. 9 feet 10 inches, that's really close to 10 inches, sorry, 10 feet. And then this is just 20 feet, so we're going to go 20 feet. Now notice we have kind of two different shapes here. We have this rectangle here and the triangle. So let's see if we can find the area of each of those. Maybe we should use different colors here. So this one, I need to find out this height from here to here. Since I know the whole height here is almost 10, right at 10, and this piece right here is 8, that means this one right here must be 2, because 10 minus 2, sorry, 10 minus 8 is 2. And the width is we're using that 10 feet. So for the area of that red one, I'm going to say 1/2 base, which is 10, times the height, which is 2. Half of 10 is 5, so 5 times 2, which is 10. In this case, it'd be feet squared for the area of that yellow triangle, or red triangle. Now for the area of this rectangle here that I've highlighted in blue, that's going to be 10 feet wide times the height, which is 8 feet. So it's going to give me 80 feet squared. Now these two areas together, this one and this one, gives me the shape of the base, right? Shape of the base. I could have also used the trapezoid formula if I would have wanted, but I didn't really want to. I'd rather find them separately. So the area of the base is going to be 80 plus 10, or 90 feet squared. So as I find the volume of this whole addition that he added onto his barn, I'm going to say big B, the area of the base, times the height. So that's going to be 90 feet squared times the height. Well, what is the height? Remember, the height is the distance between my bases, in this case 20 feet. So 90 times 20, or think of 9 times 2, is 108. So, sorry, 9 times 2 is 18, and then I'm adding on 2 zeros, one for that one for that one. So 1,800 feet squared times feet gives me feet cubed. So the volume is about 1,800 feet cubed. Your homework is on page 656. You're going to do all of the practice set, which is, I maybe done one of them for you. All of them from this lesson, that's the 95, and then 7 more of your choice.